We are all on page 23. Looking at lesson 5, number 6. Number 6 says, express 50 degrees in radian measured to 4 decimal places.
Are we skipping number 5?
I thought we did number 5. We did number 5 yesterday. We did it in our calculators. So what this really means is convert 50 degrees to radians. How do we convert degrees to radians? Times pi over 180 what? Degrees. Why does it matter that we put units? So that they will cancel. So when it says to 4 decimal places, they want you to actually plug that in your calculator. Do I have to be in radian mode? No, you don't. I can off the 0 just because that's my brain, how my brain is wired. Keep going. Make an assumption that you can do that. Number 7, 2 cosine. I put it in parentheses, the 7 pi negative, I think it was, no, it's 5 pi over 4. Minus secant pi over 4. What are you doing with this problem? This is a trig review problem that you know what these are. So you got your plate out, you're looking. Where is 5 pi over 4? Where is negative 5 pi over 4? So negative 5 pi over 4 is where? Which direction am I going? Yeah, because right there, I've gotten to negative 180 or negative 4 pi over 4. And I need to go up another. What's my reference angle? Pi over 4 or 45 degrees. So what are we finding? What is cosine of 45 degrees? Do you also need a triangle?
Yes.
45, 45, 90. Your side lengths are?
1, 1 squared is 2.
So cosine 45 degrees is? Square root of 2 over 2. Are we good? So are we just going to find that times 2? That's the first part. Are we finished with the first part?
Isn't it?
Does it matter which quadrant I'm in?
Yes.
It's going to change the whole problem if you don't make that negative. Because we're in quadrant 2. And we're bringing that 2 down, so these are reducing. So this first piece is really negative square root of 2. Next one is just pi over 4. It's happy. Pi over 4 is in the first quadrant. I don't have to draw another triangle. And what is secant, or really what is cosine, pi over 4? It's 45 degrees, but what's cosine of 45 degrees? Or really, what's secant of 45 degrees? It might be easier to find. So cosine is 1 divided by the square root of 2. So secant is going to be square root of 2 divided by 1. Right? Square root of 2. So what's negative square root of 2 minus the square root of 2? No.
Oh.
No, what's negative 1 minus 1?
Negative
2 square root of 2.
Oh.
Okay. That's probably the most common answer for this problem is 0. But it's wrong. Generally it's wrong because you forget that negative sign. Square root of 2 minus square root of 2 is 0. But you have that negative sign. So negative square root of 2 minus, because every time I see it, I add the opposite. So we have negative 2 on the square root of 2. Okay?
Nice.
Don't do the whole problem right and then be silly on one thing.
Alright, number 8.
Number 8. Are you ready for number 8? What is number 8? Tangent squared pi over 3. Minus cotangent squared pi over 3. So which kind of a triangle am I looking at? 30, 60, 90. So, well, let's do that.
Hey, you took that on poster.
Yeah, because I start the new year fresh.
I want mine.
You do? Have it. Have it somewhere.
I want to put them back up on your wall.
So, you have to wait till the new trig classes put them on the wall. Put them on the wall. It's always fun to watch. Last year's calculus class was very. When are they putting the posters on the wall? When are they putting the posters on the wall? And you're gonna do the same thing. It's not the second quarter.
Well, then,
Why can't we just put all of them?
Because then they are looking at them, and I don't want them to look at them.
okay, I'll just put mine in my backpack and I'll just break it.
Carry it in with them now.
We could just tape it up every day. Like we can hide it somewhere, like behind this board, and then just slide it out
Yeah,
and slide it back.
like the bat cave tree posters.
It'll be good. I'm here for that.
Alright, so, but that doesn't even help you on this one at all.
I know, that was just.
Okay.
For the future.
For the future. Alright, so what are the side lengths of your 30, 60, 90 triangle?
1, 30, 32.
Okay, so which one of those is pi over 3? Does everybody agree that this is really pi over 3 is 60 degrees? Yes. 90 divided by? Not really 90. Alright. So what is tangent of pi over 3? Yeah. Opposite over adjacent. What about cotangent pi over 3? Okay. Molly's gonna go ahead and you went ahead and did the
1 over 2.
oh my goodness, you already rationalized it. I was gonna say, do you have to really you do have to rationalize, but I'm fixing to square it. It doesn't matter, it should work out the exact same way. That's okay. Because we always think of square root of 3 over 3. And I want you to think of that. But it still reduces to the same fraction. So, cotangent is the reciprocal
When
of
you
tangent.
square it, is it not just 1 over 3?
Yes. So you don't even have to rationalize it if you're squaring it. So tangent squared, so square root of 3 squared is 3 minus
1/3.
1/3, which is really 2/3. What? 2/3? Maybe 2 and 2/3?
No, that's not all.
2 and 2/3? Some of you, it's okay to leave improper fractions. The majority, it was lots more than you. The majority of your answers, my answers that it gives me, are improper fractions.
Big times bottom plus top. 6.
So they just left it all
So
as fractions.
8 over 3.
Or 8 over 3. Okay. Could you do another one? Can you do this one by yourself? Sine squared. Negative 2 pi over 3. And I always put them in parentheses. The book doesn't always put them in parentheses. Because that doesn't mean they're subtracting. Right. So what is negative 2 pi over 3? In the second quadrant.
It's in the third quadrant.
It's negative. It's in the third quadrant. We didn't quite make it around.
240. So 60.
So here we've gone not quite to there. It should be pi over 3 left, which is 60 degrees reference angle. So what is sine of 60 degrees? We had our triangle up there just a second ago. When we square that, what about cosecant negative pi over 2? Where in the world is negative pi over 2?
270.
270 degrees. What do we call those right there? Remember when they didn't land in a quadrant?
Straight lines.
Guess. Thank you for putting yourself out there.
Okay. You have the equator
Okay, the x-axis
and the y-axis.
and the y-axis. Yes. So what do you call the angles that land right on the x-axis or right on the y-axis? They don't land in a quadrant.
Y angles and x angles.
Keep giving you a word. They don't land in a quadrant.
Non-quadratic angles.
Actually,
Quadratic angles.
oh my goodness, I can't breathe now.
Quite funny angles.
Quadrantal angles. 90, 170, 180, 270, 360. They are all quadrantal angles.
The line on a globe that goes through the equator, that's called the
Prime meridian.
yeah.
You know that we just talked about this in my last class, and the only reason I know is because the kids, I'm like, it starts with an M, there's an M something, and
That's
they're like,
nothing
it's
else.
the axis.
Mediterranean for some reason, but they
The meridian.
prime meridian.
Yeah. That's line geometry we were talking about. There's a question about a plane. Two planes have the same latitude and longitude.
Have you seen Sorcerer's Apprentice?
No.
This movie with Nicolas Cage and another guy, and they're wizards. Anyway, so they're trying to find the last descendant of Merlin, the Great Wizard, and they call him the Prime Merlinian.
Okay, that makes a lot of sense. Okay, do you remember what we did when we had these points on quadrantal angles? Could I pick a point right there?
Oh,
Yes.
What?
0, 1.
So 0, -1. What's my R? the radius. If I were to draw triangles, but what's the distance from the origin down? It's 1. Do you remember? This is the do you remembers.
The squared plus the squared equals the radius squared.
X squared plus y squared equals r squared. Yes, it's the Pythagorean theorem. But we also, I think, talked about sine theta was the y over r, because it's the opposite. And the cosine was x over r. So which one are we looking for? We're looking for the sine. So I'm thinking sine is my y over r. So if I flip it, it's r over y, which is 1 over negative 1. It's still negative 1. That was negative 1. Ooh, now we're minusing a negative 1. So we add the opposite. What is our answer? I know that actually, if you plug that in your calculator.
Wait, question.
7.
Shouldn't the 3/4 be negative?
7 4.
Because sine is
We squared it though. No, it is negative, but we squared it. Yes, I'm sorry.
okay.
I'm sorry. Yes. It is negative, but then we squared it. There was a reason why it didn't matter.
Yeah, because I was like, that's in the third quadrant.
It is in the third quadrant, and sine is negative, but the fact that we squared it made it positive. You know, you can also put in sine of 270 degrees, or you can put in sine of negative 90, and it'll give you negative 1.
I did that tomorrow.
Okay? So you can use your calculators for we're not doing that. Okay? He's not copying. Please. You can jump on with us and then we'll keep going and you can come back and do those. Alright. Number 10. Number 10. Sine squared, cosecant x and cosine. Can you simplify? Oh, look. Because I feel like you don't need me for.
Those fish.
They're alphas. Mine look more like fish than the books do. They're alphas. Alpha, theta, betas.
And then I was like, someone's gonna propose to you? And she was like, no, oh my gosh. She's like, this one boy likes me so much. And the little girl's like, he's in love with her.
Like little middle schoolers.
No, they were like
Third
5.
graders.
Like babies.
Little.
Like they were like little.
Like in your mom's classroom.
And I was like, she had on these like purple glasses. And I was like, it's probably those purple glasses. I was like, that's probably why he likes you so much. And she was like, I just got them yesterday. And I was like, they look so good on you. And it was just so funny. And I left and I was like, y'all better watch out for those boys because they're so cute. And they're like, I know, right? It's so funny.
Did you
like made my day. It was like the best encounter I've had today. Top bottom.
Probably all year.
It was so cute.
Alright, do you need any help with these? Do you remember what the contrapositive is?
Yes.
Gonna look good.
Yeah.
It's really bad for your eyes.
I can actually like see pretty well, except when I like kind of look to the side. But straight ahead, we're doing great. It's kind of weird to have contacts in too.
Oh, that's even worse for your eyes.
It's fine. But I look good.
Okay, can you all do the number 12, the contrapositive? What does the contrapositive do?
Is that the one that's like both instead of?
Yes, so you're switching the ifs and thens, the hypothesis and the conclusion, you're switching them,
make it positive.
and
or
you make it the
opposite.
not. The inverse is the not. So the contrapositive is the inverse and the converse all together.
So if the polygon is not the triangle, I mean, yeah, the polygon is not a triangle.
You just do the inverse. All you do is put in the not. The converse flips these two. Correct. So just a little side note, this butterfly is here watching over us today. He's been here for at least 3 periods.
We should feed him
Wait, this
What are we gonna
statement
feed
is
him?
not true.
flowers.
Let's feed him Prince.
Okay, the funny thing is, I thought, what am I going to be, a kid? It's funny that she said your name, I didn't say you.
Yeah, but you didn't defend me.
You were late. You deserve to be fed to the butterfly.
I was not late, I was excused by
Yeah. Okay, what's gonna happen, he's gonna eat Justin if Justin's foot kicks over his monster's raking my floor.
It's a Kickstarter.
I don't care.
It's not. I didn't buy it. Zach bought it. And I
It's all unnecessary. Alright,
I'll put that 40.
moving on. Can we move on?
You have to pay a 401k.
Number 13. Use the quadratic formula to find the values of x for which the value of the polygon 2x squared minus 3x plus 1 is 0. So you're trying to find the zeros, the roots, the solutions of this equation. But it specifically told you how they wanted you to find it. I think this you could find it all 4 ways. I think it's actually factorable. You can complete the square. That's way harder. Or what is the quadratic formula? You're fading away.
Oh, b squared minus 4ac over 2a. I'm sorry. I thought like other people were gonna join in, but no one was joining in. I was like, oh.
No, I was listening to you greatly.
Wait, you already did 12?
We did. I didn't write it up there because there were lots of words. And we talked about, can you do the contrapositive and the inverse and the converse and the.
Isn't it a good one to do?
Yeah, I'm like, if it's factorable, then it's doable. Is this anybody's pencil?
Wait, I blanked out for a second here. When we're saying A and B, which side do we count A from? Is that
A is going to be with your x squared. So you got an A, a B, and a C. A is with the x squared. me, number 4. We all on number 4. You all solved this using the quadratic, plugging it in. Number 14, when I first read it, I was like, oh, this is going to be hard. It is really not. It's probably one of the easiest problems we've done if you just read it and pick out the key words that you know. I kind of put them up here.
Equation.
It's the equation. Okay, you might need to know it's an equation of a line that's parallel to the y-axis. Where's the y-axis?
Straight up and down.
Straight up and down. So where is the point? So here's the y-axis. We're going to pretend that's a straight line. Where's the point 2, 3?
To the right, 2 up, 3.
So a point that goes, a line that goes through 2, 3 that's parallel to the y-axis.
Y equals 3.
Okay.
X equals. No, X equals.
I don't know. So I hear y equals 3 and I think that, but y equals 3 has a y-intercept at 3. Okay? It means it's going this way. It would be perpendicular to it.
That's what
When
I
it's
think.
going
Wait,
up
did it
and
not say perpendicular?
no, it said parallel.
I read that wrong. Then it's x equals 2.
X equals 2. It's going this way. It has an X
I thought it
intercept.
said perpendicular.
That goes, that's reading those key words.
Man, it's like 3 hours of sleep.
Why we're doing this together. Solve algebraically. Does it matter to solve
Okay,
algebraically? Just solve it.
The
Yes.
textbooks we used last year, were they Saxon?
No.
What was it?
I don't know.
Which one did you use?
What do you mean?
I think Saxon is good.
I mean, I think Saxon is okay. I mean, this is okay. This is not my favorite. I mean, I like this. It's small. It's a college book. I mean,
I think I like it. The explanations are usually
it's different. Can you solve number 15? What are you going to do? When it says solve algebraically, it just means solve it. It gives you a y equals. What should you do if it gives you a y equals already? Substitute it in so then you have y equals x squared plus 1 and then y minus 2x equals 0. I see y equals, and I'm plugging it in. That's just what I'm doing. So I see x squared plus 1, there's a 1 there, minus 2x equals 0. I'm probably going to rearrange it to x squared minus 2x plus 1 equals 0. What are you going to do? How are you going to solve for x? You can factor it. You can do the quadratic formula. You can complete the square. Plug it in your calculator and get intercepts. For 15.
Do it all.
Not.
It will factor. Yeah.
Can we just do that?
Yeah. But I just listed all 4 ways you could do it. Is it an x minus 1 and an x minus 1? Okay, I did that. I made an assumption that you can do that. But I said, so what does x equal? There's only one solution to that. Plug it in. Y is 2. So this is a parabola and something else that's only one intersection point. Is that what that tells me? There's only one intersection. And it's at 1, 2. Here we go. Given that x squared equals all of this, can you solve for y in terms of x? So the key is solve for y in terms of, so you're gonna have a y on one side and the x's on the other. So x squared equals. Can you rearrange? What's the first thing you're gonna do?
You're gonna square both sides.
Square both sides. Like,
Yeah. They just have to type it every day.
alright, so after you square both sides, what do you have? And what do you do?
X4 minus 1 equals y. Are we done?
Yeah. Could you do something with the left side?
I mean, you can put x, 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 minus y, minus 1 equals y.
Do you have a difference of squares? Could you factor it? It doesn't ask you to, but I need you to recognize difference of squares when you see it. We have x squared minus 1 and x squared plus 1. And you have to do another. You don't have to do that right now. It's not what it's asking for.
Or yes, I could do that.
You could do that. Do you recognize that that's what it is? Alright. Can you finish 17 through 21 for Monday?
Sure.
17 through 20. You still got 2 minutes to work. But your homework is 17 through 21.